simple introduction to geometry, and then we're going to learn what some of the things mean. So some of them you probably already have a good sense of what they mean, and then some of them maybe mean something a little bit different in geometry than what you're used to. And some of them are pretty self-explanatory, but in math, we always focus on definitions because we like to be very precise when we're talking about things and know exactly what we mean. So here are the first three definitions and pictures, which I think are helpful. So we've got a point. So think of it as like a little dot, but in reality, it doesn't have any length or width or thickness. So it's like the tiniest little pinpoint you can think of. And we label it usually just point A, like you see here. For a line, think of 2 points and then we connect them. So anytime you have at least 2 points, you can draw a line between those 2 points. There's only one way to connect them. So you may have heard people say 2 points determine a line, because as soon as I pick 2 points, there's only one way to draw the line. And then when we draw them, we put the arrows here and here to show that it's going on infinitely in both directions. And so we might write line AB like this, or we also use this notation. So we write the A and B together with a little line over them. And then we have a plane, and for a plane, think of like a piece of paper, like a sheet of notebook paper that extends in in all directions, so infinitely. So just like the line goes in both directions infinitely, the paper is just spreading out. Or think about like a wall, if it could go in all directions and keep extending. So a plane is flat. There's no boundaries, but you can see that we can draw a line or draw something on it. So it's a surface. Okay, and we don't really have any we just call it plane P. We don't have notation for that one. We talk about lines a lot. And then related to lines and very similar to lines, so we can take those same 2 points. So let's draw our line here. So here's the line that's connecting these points A and B. And we call that line AB with a little line over it. And we can do what we call half of a line. So instead of going all the way in that direction, I'm just looking, so I might have something like this. A, B, C, okay. And then so half of the line would be either this is half of a line or this is half of a line, okay. And we're not, and I kind of drew this one wrong. Let me fix that one. Oops. So for this one, let's use a different color so you can see it. So we're not including that point there. So we're just leaving off that little point. So the point B isn't part of either of these half lines. That makes sense? Now, if we include the endpoint, then we have a ray. So a ray is a point. So we start at some point and then go infinitely in that direction. So this ray, I would write like this DE. So, and I show which side is going infinitely by putting the arrow on that side. And then we have a line segment which stops. So you have those 2 points, and instead of going infinitely in every direction, we stop here. So this is segment JK, and we use that. Does that sound familiar?
Yeah.
Yeah, you may be seeing some geometry. Okay. Yeah. So that's our definitions and also our notation. And then here's some more examples of that. So line AB, and we can call it either AB or BA, it doesn't matter, they're the same, right? But for this half line, it's half line AB. Okay, so it starts at A and it goes infinitely through B. And notice that we leave an open circle here to show that we're not including that endpoint. And then we have the ray and then the line segment. And again, the line segment, we can call it AB or BA, they're equivalent. Doesn't matter which one we start, but the ray and the half line both have a set starting point because they don't go infinitely in both directions. And then we take this idea of the ray and we extend it and we put two rays together and they have the same starting point. So we start at this point B and we go infinitely through C here and then infinitely through point A here, and we call that an angle. And when we extend this idea and we start talking about measures, we talk about starting from one of them. So if I think about starting here, then this would be my initial side. And then I'm swinging the other one up to here, and I call this the terminal side. And then we have lots of different ways we can name the angle. So sometimes we name the inside, and we call that one angle 1. We can also call it angle B. We can also give names to each of these sides, and we can call it A, B, C. When we have something like this, for this one, if I'm talking about any of these angle A, I have to be specific. So angle A here is confusing, right? Because do I mean the angle that goes through B, then A, then D? That's angle BAD. Or do I mean the angle that starts at C and goes from C to A to D? Or do I mean the angle that starts at B, goes to A, and then goes to C? So whenever we have multiple rays, more than two, then we can't just name the angle with a single letter. We have to be specific so we know what the angle is. Okay, and then we measure angles, right? So we measure the amount of rotation from the initial side to the terminal side. So we start at that one side, we swing it up until we're ready to stop, and then we measure the number of degrees. And we have, if we go all the way around and make a full circle, so in other words, my terminal side and my initial side are the same. So I start here and I swing all the way around and then I end up here. So that's 360 degrees all the way around. So that means that if I start here and swing over to here, how many degrees would that be?
It's not 180.
That's right, that would be 180 degrees. And if I start here and I swing around till I get here, and this makes a perfect square, how many degrees is that?
90.
Yeah. Mhm. And then if I just go 1/360th of a rotation, then I would have a 1-degree angle. So these are the 360, 180, 90 are some common ones that we talk about a lot because they show up in a lot of equations and things. And then we might have a problem like this one. If you think about an old clock, the old types of clocks before we had all of the digital clocks, but this is still often used as an example because it's made in a circle. So if we think about starting here and spinning all the way back to here, then we have 360 degrees. And so if we break it up into let's just think about from here to here, well, there's 360 degrees all the way around the clock. And then there's how many numbers?
12.
12. So 12 goes into 360. How many times? How about into 36?
Yeah. When I did on the calculator, it said 30.
Yeah.
Okay.
Yep. So 360 divided by 12 is 30. So that means that in between any two numbers, we've got 30 degrees.
Hmm.
So from 12 to 2, we've got 30 plus another 30, so we have 60.
Okay.
And then another like common question would be in an hour, in 1 hour, so in an old clock like this, we call it an analog clock because it's not digital, it's analog. So, and there's usually, right over here, there's usually a longer hand and a shorter hand. And this one counts the hours, and this one counts the minutes. So there's 60 minutes in an hour, which means in an hour, this minute hand goes all the way around 360 degrees. Okay. And then we have special names for some of these angles. So you told me about that 90-degree angle. We call that a right angle. And then that 180-degree angle we call a straight angle because it makes a straight line. And then an angle that's less than 90 is so cute and little, so we call it an acute angle. And one that's bigger than 90 but less than 180, we call an obtuse angle. So this angle here is obtuse. Whoop. My Alrighty, and then one way of measuring is with a protractor. So if I wanted to use a protractor to measure an angle, then I have to first put this part of my protractor, there's usually like a little hole there, and I have to line that up with the vertex of my angle. And then I line the straight edge with my terminal side, and then I look and see, or sorry, my initial side, and then I look and see where does my terminal side hit. And then notice how there's two numbers. So which number do you think you would use?
Would be the top one.
So if I'm looking at, if I'm thinking about the measure of this angle,
Hmm.
does it look like it's more than 90 or less than 90?
Like more.
Like this is 90 degrees, right?
Hmm. Yep.
So this is less than 90.
Oh, wow.
Yeah. So this is the
Yeah.
bottom number. This is 50 degrees. Right? Because 90 is
Oh,
up,
so like
have to go all the way
the
up here.
smaller the little curve, like the bigger the angle is. Oh, because it like,
Yeah.
and now I get that. Okay.
Yeah. And then we said there's 180 degrees in that straight angle, right? If I go from here
Yeah.
to here, it's 180.
Yeah.
So that means then if I go the rest of the way, so I already went 50, if I just want to go from here to here, so I have this angle that goes, starts at C, goes from B, and then over here to D. So angle CBD.
Mhm.
That one is going to be how many degrees do you think?
Would it be CBD? Wait, would it be 50 plus 180 or would it just be 180?
Okay, so the green starting
Mhm.
at AB and going all the way over here to D, that's 180, right? That's the straight angle.
Yeah.
And then starting here and stopping here is 50.
Hmm.
So if this is 50 and then I have to keep going to get to 180, how many more degrees are there?
Oh, would you do 180 minus 50, right?
Yes. Yeah.
Would be,
And that's exactly the number up here, isn't it?
oh yeah.
So when you look at oh, it's probably hard to read. So when you look
No,
at
I
a
can see.
protractor, so this one just says 90, but this line has 80 on the top and 100 on the bottom,
Mhm.
70 on the top, 110 on the bottom. So they all add up to 180.
Oh, that makes sense.
So the way that you read it is the smaller angle is always the smaller number.
Hmm.
The bigger angle is the bigger number. And so that's how the protractor works.
Are we gonna have to use the protractor or like
You might see one
online
or two,
one?
you might see one or two problems in the homework.
Mm-hmm.
So we have like some homework sets and then it randomly picks some, so you could see
Okay.
that. Did you have any other questions about it?
No, I was just wondering because I was like, do I need to like get a protractor?
Oh, no, you don't need to get one. So if there is a protractor question, it would look like this.
Oh,
Yeah. And it would just ask you to explain it. And then we give special names to two angles who either add up to 90 to make that right angle or add up to 180. When they add up to 90, we call them complementary. And when they add up to 180, we call them supplementary. When I was learning this, it helped me to remember alphabetical order. The C comes before because I'd be like, which is complementary and which is supplementary? So the C is first in the alphabet. That's the smaller one. The S is second. That's the bigger one. So that's another way of thinking about what's the difference between complementary and supplementary. And then we talk about if one angle is 70 degrees, its complement is 90 minus 70 or 20. If an angle is 110 degrees, its supplement is 180 minus 110 or 70. So if you're asked to find a complement, it's just subtract that angle from 90 and you get the complement.
what if it was like,
This-
what's the complement of like 110? Would you still do 90 minus 110? Would it be like, or no, would you 110 minus 9 or
It would be no, there isn't one.
okay, they just will ask you that. Okay.
Yeah.
Okay.
Yep. So a 110-degree angle doesn't have a complement. Great question. Yeah.
Oh, okay.
No complement. Mhm. It's only true if they add up to 90. So if one of them's bigger than 90, it doesn't have a complement. If it's bigger than 180, it doesn't have a supplement. All right. So another way you might see a question like this about complements or supplements is you might see a picture like this. And so do you know what this little square means?
Is that the 90-degree
Yes.
angle? Okay.
Yes, the square means it's a right angle, which is 90 degrees. So we know that this whole angle has to be 90. So if this part is 62, the other part must be 90 minus 62.
Mm-hmm.
So you might see a picture like that. And then we can kind of extend on this idea. Now we can create an algebra problem from this. So we have this angle ABD. And we can see that ABD and DBC, so this is ABD and this is BCD, and are they complementary or supplementary?
Supplement.
Yeah, they're supplementary. So they add up to 180. And we don't know what either of them measures, but we know that ABD is bigger than DBC by 66 degrees.
Mm-hmm.
So that means if I call this one X, and this one is 66 degrees bigger, what would this one have to be?
That two, right? Or
If it's 66 degrees bigger,
oh,
that means whatever the other one is, I have to add 66.
oh,
Yeah. So, and I know that this angle and this angle add up to 180, so I can create this equation here. This is the smaller angle we said was X. This is the bigger angle that's 66 degrees bigger, and they have to add up to 180. So now we have an algebra equation we can solve. So back a couple of weeks, I think, was when we did this. So we're just going to combine our like terms. I have an X and an X, so I have a 2X. And then I can subtract that 66 from both sides to get 2X is 114. And then I'm going to divide both sides by 2. And they want the measure of each angle. So I found that X is 57. So what would this angle be then?
Just 66 plus 57.
That's right, 66 plus 57, which is 123. And then I can check. So if I did it right, these two angle measures should add up to 180, right?
Mm-hmm.
Do they?
Yes, I did it earlier, or like
Oh,
I did that problem earlier.
okay,
Because I was
great.
like confused at first, but then like I made sense of it, and I was like, okay, that makes sense.
Yeah, sometimes you have to, you got to give yourself a chance. Sometimes you got to read
Mm-hmm.
things a few times. Yeah. Okay, and then we have vertical angles. So whenever I take two lines that intersect, so they meet in
Mhm.
just one point, then the angles that are opposite one another, we give them a special name, we call them vertical angles, and they are equal to one another. So these two angles here, if this one's 68 degrees, that means this one is 68 degrees.
Yeah.
And then we can also find angle 2 and 3, right? How would we find those?
Are those equal too, or no?
What do you think? Do they look equal?
Yes, they do.
Well, let's draw it a little bit differently. Okay. Now let's pretend, we're just going to pretend this is 33.
Mm-hmm.
So that means what's this one?
33.
33. Now, what do you know about this angle and this angle?
Hmm.
This is a straight line here, right?
Yes.
A straight angle has how many degrees?
180.
Yes, that means they're supplementary. So this one has, what would be the measure of this one here?
Like, would it be half of 180?
So remember, supplementary angles add up to 180. So if one
Mhm.
of them's 33, the other is going to be 180 minus.
Minus 33.
Uh-huh. Yeah. So what's that? 147.
Yeah.
So what's this one?
So that'd be 147 too.
Yes.
Okay.
So then back to this one, we said this guy's 68. What is this one going to be then?
But 180 minus 68.
That's right. Mm-hmm.
So 112.
And this one is
112.
also 112.
Okay.
Yes. Uh-huh. So anytime I have those two intersecting lines, as long as I know one angle, I can find all four of them.
Mhm.
Okay, because they're the ones that are next to each other add up to 180, and the ones that are opposite each other are equal. So I really only have to do one calculation, 180 minus the angle, and then I know every single angle in that set. And then related to that, another, have you seen this before?
Yeah.
Yeah, so another special relationship. So parallel lines are two lines that are in the same plane and they never meet. So they're always the same distance apart, they'll never meet. And they have to be on the same plane. So we can have something that we call skew lines. So I have this line here and this line here that will never meet, but they're not on the same plane. So they have a special name. So parallel lines, I can draw them on the same piece of paper and they don't have any common points. And if I take these two, so these two lines are parallel here. We also have a way of denoting that. So to show parallel lines, we'll do this. And that means those two lines are parallel, just putting that extra little hook in there. And then if we take a line and draw it through both of them, then we call that line a transversal. It transverses or crosses over both of them. So it's called a transversal. And you can see that the transversal intersects both of the parallel lines, doesn't it? And so up here, we have that same situation we had in the previous page. If I know any one of these angles, then I would know all of them, right?
Yeah.
So let's say, I'll make it easy. Let's say this is 60 degrees. What would this one be?
Would that be 62, or would that be the supplement?
This is the supplement. So the same
Oh,
ones are
it's-
opposite each other. So this is the
Oh, that would be 180 minus 60,
Mhm.
120.
One. And if you forget, just kind of, kind of think about it. Like this
Oh
one
yeah,
you
those
can
are
see is
like
bigger,
equal.
right? Yeah.
Yeah.
Yeah. Okay. Now we have this information. And then we also have, let's look in, we have some special names that we give to all of these angles. Hold on. My board gets in the way and then I have trouble moving my mouse. Okay, there we go. All right. So I love this drawing because you can see exactly what it's talking about here. So any two angles that are inside, so on the inside of the parallel lines and then on opposite sides of the transversal are called alternate interior because they're on the interior of the parallel lines and they're on alternate sides of the transversal. Okay. And it turns out they have the same measure. So if I know this angle, I also know
Yeah.
this angle. But then if I know this angle, I know this one is the
You know
same.
this
So
and
this one's,
7.
yeah. And then all the other ones I can find by subtracting from 180, right?
Mhm.
And they're all the same. So as long as I know any one angle, I know all 8 of them. We can also solve one of these problems if we're given alternate exterior angles, right? Since, let me erase some of this. Since these two are equal, then for alternate exterior angles, this one's on the alternate, or these two are on opposite sides and on the exterior, so these would have to be equal as well, wouldn't they?
Mhm.
And then we have what are corresponding angles. So because we know that all of these have to be equal, we know that these two that are both on the bottom of the parallel lines have to be equal. These two that are both on the same side and on the top of the parallel lines have to be equal. So that's how, as long as we know that two lines are parallel, we can figure out what all of the angles are. And it works in the reverse, or we call the converse in geometry. So if I have two lines and they're intersected by that third line, the transversal, and if those angles are congruent, then I know that the lines must be parallel. So we use this in geometry to prove a lot of things. So you'll definitely see some problems like this in your homework. And so they'll tell you that you've got parallel lines and they'll give you one of the angles. So if I know that this angle 8 is 35, what other angles do I know must be 35?
Um, is it, wait, is it 2 or 4?
Yes, 2.
Okay.
Because these two are alternate, they're on
Yeah,
opposite sides and
uh-huh.
they're interior.
Okay, alternate interior.
And you can also kind of, this one you can kind of cheat a little bit because the bigger
Mhm.
angles are really big, right?
Yeah, that's
You can
true.
kind of see which ones are small. What are the other two 35-degree angles?
Um, it'd be,
So remember vertical
uh,
angles. Which angle is opposite this one?
the, wait, 4 or 5?
Um, yeah, so see if it's 5. See how these guys are opposite one another?
Oh yeah. I feel like I just got confused because like the 2, it's like it looks huge and 5 looks small. But I
Oh,
look at the
yeah.
angle.
Mm-hmm.
That makes
So
sense.
this one's 35. What other one? There's
Mhm.
one more.
1, right?
Yep. Mm-hmm. And then to find the other ones, how do I find the other 4?
You just subtract 180 from those,
Yeah, so they're
right?
all going to be 145. Yeah.
Yeah.
Mhm. Okay, so I have a couple of, let me see. Come on. Right this way. There we go. Couple of problems from last time. Oh, it wants me to click. There we go. Okay, let me share this guy. Okay, so you can see a couple problems
Mm.
here.
Yeah.
Okay. All right. Annotate. Okay. Okay, so some of the problems might look like this. Does the following statement make sense? And then usually these are multiple choice. So a good approach to this is to first decide whether you think it's true or not, and then think about why, and then try to find the one that matches you. So for this one, let's see, the spokes of a bicycle wheel are perpendicular to the rim. So they are parallel to each other. Let's see. Does that make sense? The spokes of a bicycle wheel. What does that look like? Like this?
Mhm.
Yeah. Um, what does that mean to be perpendicular to the rim? Oh, so let's think about if this guy is perpendicular to the rim, then we have a, if we draw a line here, we have a 90-degree angle, yeah?
Yep.
Okay. So let's draw another one here. That means it's perpendicular here. What do you think? Do those look parallel to each other?
No.
No,
Yeah.
doesn't make any sense, does it?
Mm-mm. Well, 'cause aren't they parallel? They're not supposed to like connect at a.
So yeah, if they were parallel, they wouldn't intersect, yeah.
Mhm.
Yep. So a line parallel, let's draw another one. So if I think about this one being perpendicular, then a line parallel to this one would be like this, right?
Yeah.
That wouldn't be a spoke, would it?
Mm-mm.
Okay, let's see. If an angle measures 135 degrees, find the measures of angles 1, 2, and 3, assuming they're formed by a transversal intersecting two parallel lines. Probably need a picture for that, right?
Yeah.
I think I meant to include a picture. So let's say these two are parallel.
Mm.
This one looks like 135 degrees. So let's find 1, 2, and 3.
So would 3 be 135?
Yes.
And then 1 and 2 would just be 180 minus 35?
Yes. Exactly. Great.
Okay.
Yep. And we know all the other ones too, don't we, if we were asked?
Yeah, because they're like.
Mhm. Sometimes it's easier to just draw them all in and then figure out which ones they
Mhm.
want you to answer. Here's another one of these. Does this make sense? An angle is formed by the intersection of two rays that have a common endpoint. So you could go back and look at your definition.
Mhm.
You might also think about drawing this. So, So a ray is like this, right? So there's a ray. And then if I have another ray with a common endpoint, then that would look like that, right?
So yeah, that's true. That makes
That's true.
sense.
That's exactly the definition of an angle, isn't it?
Mhm.
Yeah.
Yeah.
Yeah. So if it's at a line is formed by the intersection of two rays that have a common endpoint, then you might say, well, it could be, right? We could have a straight angle, which is a line,
Mhm.
but it could also be any other angle. So if
Yeah.
this said line instead, we would have to say no, could be a line, but it's probably not a line. There's lots of other
Mhm.
ways it would be an angle and not a line. Yeah. Mhm. Okay, that's all I had. Are there any problems that you've been working on that you want to